Hello everybody, welcome to the PiThagoras channel, and today we will be discussing the differences between long division, synthetic division, when to use them, when not to use them, why to use them, the value of using them, and all of that. And here, I'm going to start us off with a long division problem because that is the basis of synthetic division. So, how do we long divide? The first step is going to be, we're going to write out a bar, so we're going to have x squared minus 2x minus 3x plus 1. This would be a 3. Minus 3x plus 1. And then we write the long division bar as you wrote in elementary school. And we have, I'm going to write this a little bigger for you guys to see. So we write x squared minus 3x plus 1 long divide bar, and then what we have is going to be 2x to the 5th plus x to the 4th minus 3x cubed plus 6x squared minus 6x plus 9. And now what we do from there is we want to figure out what we multiply this leading number by to get this number that we have right here now. So 2x to the 5th divide, we can just divide 2x to the 5th divided by x squared. That leaves us with 2x cubed. So 2x cubed, and now we're going to multiply everything by that. And that means we have 2x to the 5th, and then we have plus 2x cubed times negative 3x minus 6x to the 4th, and then times 1, that's going to be plus 2x cubed. Now the next step is we flip the sign on everything. So subtract, and then add, and then subtract. So this is going to give us 7x to the 4th minus 5x cubed, and then we bring down this. So plus 6x squared. And now what we want to do is the same process again. 7x to the 4th divide x squared, we get 7x squared. So plus 7x squared, and then 7x squared, we of course have 7x to the 4th over here, and then after that 7x to the 4th, 7x squared, then this is going to be minus 21x cubed, and then what you have next times that times 1 is of course just going to be plus 7x squared. Now we are going to flip the signs, add, subtract, and this is going to become 0. This is going to become 16x cubed. This is going to become minus x squared, just 1x squared. And then we're going to drop down to negative 6x. So minus 6x. Now, what do we multiply? We divide this, we get plus 16x. It is a little cramped up there, but right now I'll rewrite our bar. What we have right over there is 2x cubed plus 7x squared plus 16x. That's what we have so far on our bar. And then what we're going to do, multiply it out, 16x cubed. These two terms are always going to match up. And then after 16x cubed, we have minus 48x squared, and then that is going to be plus 16x. Now, as always, flip the sign, negative, positive, negative, and then what we have is these become 0, of course, and then this becomes 47x squared, and then this minus 22x. And then we drop down our plus sign, and we do our last round of multiplication. This is just going to be plus 47, which I'll just write over here since we're running out of space over there. And that's going to be plus 47. And now, what we have is just multiply it out by that constant term, so 47x squared, and then 3 times 47 is going to be negative 141, and then after that we have 47 times 1, which is just going to be plus 47, subtract, add, subtract, and evaluating this all out. 141 minus 22, that is going to be 119x, and then 147, 9 minus 47 is going to be negative 36. So, what we should get is, as our final answer, is going to be it's going to be all this plus this remainder. And what we do with that remainder, we just put it over x squared minus 3x plus 1. So 119 and then minus 36 all over x squared minus 3x plus 1. And now we have like that. That right there is our fully divided form of long division of these two polynomials. And now we're going to take a look at synthetic division. And now synthetic division comes in handy whenever you're trying to find the zeros of a polynomial, like I did in the last video. Synthetic division can be applicable, but it is a less common use case than long division because long division works on any degree. However, synthetic division only works on linear polynomials, where even if you were to use it on a scaled linear polynomial where there's a multiple from the x, you have to do some manipulations to get it to work. However, we're just going to look at these two basic linear ones. And now, to synthetically divide, what you have to do is you have to set this linear term equal to 0. So x minus 2 equals 0. And we have to solve for x equals 2. So now we know what we're going to synthetically divide by. And I like to draw it like this. And I'll put one little bar to separate the remainder. And then we're going to drop down the coefficients. But we can't forget to consider the fact that there's a 0x cubed here. And while we omit it from the original equation, it is still important because we need to have all the degree terms here. So we're going to write that 5, 0, and don't forget your negative signs either. So then we have 0, 3, negative 6, and then 2. And now we're going to do, you drop down the first term. This is just 5. And then 2 times 5 is 10. Then you add these two together. 0 plus 10 is 10. 2 times 10, 20. Add these together, 23. 2 times 23, 46. Negative 6 plus 46, 40. 2 times 40, 80. 80 plus 2, 82. And these are the coefficients of your polynomial. However, it's just 1 degree less. So now what we're going to write down is just going to be 5x cubed plus 10x squared plus 23x plus 40, and then we have 82 over x minus 2, this linear factor. So that now is the answer to that synthetic division problem. And now what we're going to do from here is we're going to do a speed comparison and see how much faster synthetic division can be when it applies. All right, now we're going to time synthetic division starting now. 0. And then 2, 4, negative 1, that's 7. Here, 120, then 124, then negative 4. 124 times negative 4 is going to be negative 4, 96. And then after all that, negative 4, 97. All right, and that leaves us with 7x squared minus 30x plus 124 plus minus 497 over x plus 4. And that's the answer to that polynomial. Now, the same division, but with long division. Starting now. So 4. Division bar, went along. 7x cubed minus 2x plus 4x minus 1. Then we multiply this by 7x squared. 7x cubed, subtract, don't forget that we multiply this, 28x squared, subtract this, minus 30x squared. Then we have bring down to 4x plus, then this has to be minus 30x, minus 30x squared. Then negative 30 times 4 is going to be minus 20x, and then plus this becomes 0, 124x, and then what we have, bring down minus 1, and then add 124, and then 124x minus 124, not 124, 124 times 4, which is 496, then plus minus this minus 497. And what that means, this equals 7x squared minus 30x plus 124 minus 497 all over x plus 4, and that is the result of the long division. And as you can see, it did take a little bit more time to go through the long division. However, the only benefit to long division is that it works with higher order polynomials like x squared. And basically, that'll be the video for today on long division compared to synthetic division. Thanks for watching, and I'll see you guys in the next one.